Hello everyone, my name is AMMAJIRAO, and so far we have seen four methods. If you see, like in the beginning, we have seen firstly variable separable method, second one Leibniz form, third one Bernoulli's form, fourth one is homogeneous equation form. So now in this session we are going to see method 5 called as non-homogeneous differential equations form. In this, the form looks like dy by dx is equal to ax plus by plus c over a dash x plus b dash y plus c dash. Actually, it is almost actually in this hiddenly it is carrying homogeneous form, except one thing that is called constant. It means if you remove this last term c and c dash, the equation become homogeneous. If the equation is homogeneous, you know how to solve it by putting y is equal to v into x. You simply substitute it and then you can do variable separable, then solution you will obtain. But here in this case, but c and c dash how to remove, so that is you have to check. But in the non-homogeneous differential equations form, there are two cases. The cases you have to check is, first suppose if the given equation is looking in this form, firstly you have to check a over a dash, is it equal to b over b dash? If it is not equal, if a over a dash is not equal to b over b dash, then there is a procedure to solve the problem. If a means here coefficient of x, b means coefficient of y, in the denominator part a dash and b dash are coefficients of x and y. So if a over a dash is equal to b over b dash, there is a particular procedure to solve this one. There is a particular procedure to solve this method. This is another case, but now we will see the case 1 only. If a over a dash is not equal to b over b dash, if that is the case, how to solve? I told you even in the beginning, hiddenly it is carrying homogeneous form. How? When c and c dash are removed, then automatically it will become homogeneous. So to do that, to remove that constant term, there is a particular procedure to do. That procedure is, so case 2 we will see in the next session mostly. So case 2 you no need to think about as of now, think about it. So now case 1, so if a over a dash is not equal to b over b dash, let us say that is the case. Now in that case, what you have to do is, first put x is equal to, small x is equal to capital X plus h, small y is equal to capital Y plus k. Then what the equation become? Dx become, possibly if you differentiate both sides, d small x is equal to d capital X, dh becomes 0 because h is constant, d small y is equal to d capital Y. Now, so dy over dx, now equation 1, let us say this is the given equation. Now that can be converted into d small y, it means d capital Y, d capital X, because dx is equal to d capital X, d small y is equal to d capital Y. So a into small x, nothing but a is equal to capital X plus h plus b into capital Y plus k plus c over a dash into capital X plus h, b dash into capital Y plus k plus c dash. Next step. I am taking case 2. Case 2 I am taking. So d capital Y over d capital X is equal to a into capital X plus h. So that is, I am writing like a into capital X, a into h plus b capital Y plus b k plus c over a dash capital X, a dash H B dash capital Y B dash K plus C dash. Now the same equation I am writing in this form. Still I am going to solve this one. A capital X B capital Y means first term and third term I am taking. Remaining terms I am writing here. AH plus BK plus C over A dash X plus B dash Y. Third term I am writing in the second place plus remaining terms I am writing here. A dash H plus B dash K plus C dash. Now what is the case? Actually same, it is looking like in the beginning equation, like still it is not homogeneous, but I can make these two terms become zero because H comma K are I selected. H comma K are two variables I have selected, so that I can take some variables H comma K so that this term and this term become zero. It means in the numerator part what is there in the bracket, that term and this part I can make it zero by selecting a selected H comma K values. So how to do that? So try to make AH plus BK plus C is equal to 0. A dash H plus B dash K plus C dash is equal to 0. These are the two linear equations having two variables. What are the two variables? H comma K are the two variables. You know how to solve that equations. You can use your MS or ES calculator to solve this one, or there is a direct method if you want. If you put H, here the two variables are H comma K, H K one like that, you put H over, see this term, right? So B C dash minus B dash C, B C dash like this actually, arrow down to arrow up, cross arrows. B C dash minus B dash C is equal to K over, this is the middle, like, so C from here to C A dash minus A C dash, A C dash is equal to 1 over this term, like A B dash minus A dash B, A B dash minus A dash B. Like what I'm doing actually, cross terms I'm taking. So by using this set of equations, you can calculate H comma K. H is equal to BC dash minus B dash C by AB dash minus A dash B. In the same way, K is equal to this term you take top, automatically you will get H comma K values. So you will get H comma K values only here. But what you are doing, AH plus BK plus C and A dash H plus B dash K plus C dash, these two parts you are making zero. So your final equation become, now let me take this the equation 2. Now 2 becomes, what will happen? D capital Y over D capital X is equal to A capital X plus B capital Y over A dash capital X plus B dash capital Y. That's it. Now the equation is in, so now the equation is in homogeneous form. Now the equation is in homogeneous form. So if it is homogeneous, if the equation is in homogeneous, now what to do? You know that capital Y is equal to, put capital Y is equal to V into capital X. You both sides differentiation, you do d capital Y by dx is equal to V plus dx by dx, 1 plus x into dv by dx. Then what is the next step? You have to, there is the step 1 actually. Step 2, in the homogeneous equation method, what you have to do? Separate the variables. Separate the variables. So what are the variables here? V and capital X. Third one, final solution. That's all, you will get a solution. But remember here also one thing, finally you are getting solution in terms of V and X, but that is wrong actually, right? You should not stop there. V you have to replace with capital Y and capital X, and capital Y and capital X they have not given in the problem. If you go to the first page from the beginning, if you see the question is like form dy by dx, ax plus by plus c. These are the small x, small y. But what you are obtaining here in the page 2, capital Y, capital X in the solution you are getting. It means what is capital Y in terms of small y, what is capital X in terms of small x, where from we got that. So you have to change that one also. Capital Y is equal to small y minus k, capital X is equal to small x minus h. H comma k are anyhow, they are constants. So you can make it. So finally, your total solution you have to convert into small x and small y terms only, because the question is given in small y and small x. Y as a dependent variable, x as an independent variable. So you have to convert it. If you stop with v, it means you stop. If you stop here with v and x terms, that is not up to mark, like it is not complete solution. Even after v and x, you have to convert into small x and small y. So your question, how they have given, in what variables, your answer also, it means your solution also should be exist in that particular variables only. So now with this, the theory behind the non-homogeneous equation form of case 1 is done. Now we will solve a problem. So the problem is looking like this. Dy over dx is equal to y plus x minus 2 by y minus x minus 4. Small y, small x here. These are the terms. So little I am changing little. The given equation is, because first y terms came, to avoid confusion, I am converting this equation in this form. Dy over dx, small x, small y, small x plus y minus 2 over minus x plus y minus 4. How it is looking like now? Exactly, it is non-homogeneous form. Ax plus by plus c over a dash x plus b dash y plus c dash. Now it is exactly looking like this form. Now c and c dash, minus 2, minus 4. Because of that minus 2 and minus 4, the equation become non-homogeneous. If really minus 2, minus 4 is not there, happily I can solve by using homogeneous form. I can put y is equal to vx and I can solve that problem. So because of this minus 2, minus 4, the problem came. So I have to change it. I have to convert into homogeneous form. How to convert into homogeneous form? Firstly, so here you know that just it resembles ax plus by plus c. So a is equal to 1, b is equal to 1, c is equal to minus 2. This much, brief thing is not required, but I'm taking as it is first problem. A dash is equal to minus 1, b dash is equal to 1, c dash is equal to minus 4. So now, so what is the first step I have to do? Put x is equal to small x is equal to capital X plus h. Small y is equal to capital Y plus k. What is small dx? Differentiation of small x is equal to differentiation of capital X, because differentiation of h is equal to 0. Differentiation of small y is equal to differentiation of capital Y, because dk is equal to 0. So now, the question, this is the question, right? So this is the question. Okay, I'm writing equation 1 now. So 1 I'm writing now. One equation I'm writing. D small y, sorry, d small y become d capital Y. D small x become d capital X. Small x, how much? Capital X plus h. Small y, how much? Capital Y plus k. Minus 2 over, what is minus small x? Small x means capital X plus h. What is small y? Capital Y plus k. What is constant c dash? Minus 4 here. This is the equation. The same equation I'm writing like this. Dy over dx is equal to capital X, capital Y plus h plus k minus 2 over minus x plus y. X and y terms I am taking front side. Later on I am writing the constant terms. Minus, actually I can write plus H is minus, actually, this quotient is. So minus H plus K minus 4. Now see, the terms which are there in bracket makes my equation non-homogeneous. So I have to make them 0. So make H plus K minus 2 is equal to 0, minus H plus K minus 4 is equal to 0. So now two linear equations having two variables h comma k. You have to calculate h comma k so that this numerator part in the bracket and denominator part in the bracket should be equal to 0, so that my equation become non-homogeneous. Sorry, my equation become homogeneous. So how to calculate h comma k? You can solve. There are different methods I told you. If it is in, I go for rough here to tell you little thing about solving equations. If it is two variables or three variables, you can calculate by using your calculator, MS calculator or ES calculator. Please try to find how to solve that one, so that it will be easy, actually. Because as an engineering, problems, there are lengthy problems will be there. Everything you cannot solve by using your pen and pen like. And if it is a quadratic equations, that is also there is a provision to solve this one quadratic equations or cubic equations. Up to cubic equations you can solve of one variable, like ax square plus bx plus c is equal to 0. This you can solve it by using calculator, and you can calculate this one also, ax cube plus bx square plus cx plus d. I think up to fourth term it's not possible by using calculator. Here also up to three variables you can do. It means ax plus by plus cz is equal to some constant c1. Yeah, a2x plus b2y plus c2z is equal to some k1, some constant like that. Three like that. Another equation you take, a3x plus b3y plus c3z is equal to some k2. So a1 you take, b1 you take, c1 you take. Now here see, there are the three equations, three variables, x comma y comma z are three variables. So if you want to calculate the three variables or two variables, you can solve by using your calculator. Please use that. Now I'm going to third page. So you can solve however whatever the method you want. Even one method I have told you beginning in the theory, like theory I have told you, right? Some direct formula. H by bc dash minus b dash c is equal to k by ca dash. This formula also you can apply. This also you can apply to calculate h comma k values. So writing h comma k values directly. So I mean by using the method what I have taken, h over, if you do the same thing what I have done, 1 into minus 4 minus 4 minus 1 into minus 2, it means plus 2, k over, so minus 2 into minus 1, so plus 2, like this. Now minus 1 into minus 4, it means plus 4, is equal to 1 over 1 into 1 minus 1 into 1 minus 1, it means minus of minus plus 1. So 1 plus 1. It means simply like I am telling you, h by, like this I am doing, k by same way, cross multiplication. That k you leave it. You can do this one. If you have any problem, you can post your question doubts, so that I will explain in a separate manner, like the particular things. So here what you will get is, if you do this one, h is equal to minus 4 plus 2 minus 2 by 1 by 1 plus 1, it means 1 by 2. It means minus 2 by 2. You will get minus 1. K is equal to 2 plus 4, 6 by 2. It means you are getting 3. It means h is equal to minus 1, k is equal to 3. These are the two values that satisfies these two equations which are there in bracket to make the bracket terms become 0. If they are 0, then what if this equation become d capital Y by dx is equal to capital X plus capital Y by minus capital X plus capital Y. That's it. These terms become 0. So now I go to page 4. So now my equation become d capital Y d capital X is equal to x plus y. That term becomes 0. So I am not writing, by minus capital X plus y. Now it is which form? It is homogeneous form. Now, if it is a homogeneous form, how to solve? We know that already we have seen in the previous session. So put y is equal to v into capital X. That implies d capital Y is equal to v plus capital X into dv by dx. UV formula I have applied here. So dy over dx is equal to, you know that dy over dx is equal to v plus, means dy over dx is equal to v plus x into dv over dx is equal to capital X plus capital Y. Capital Y means v into capital X by minus x plus y. Y means capital V into x. So v plus x into dv over dx is equal to x. If you take common, you will get 1 plus v by minus 1 plus v. Now v terms I am taking that side. X into dv over dx is equal to 1 plus v by minus 1 plus v minus v. You do LCM. Left hand side, leave it like that only. Right hand side, you take, if you take minus 1 plus v as an LCM, something like 1 plus v only you will get here, minus v into minus 1 plus v you will get. So the equation become x into dv over dx is equal to 1 plus v plus v minus v squared over minus 1 plus v. So x into dv over dx is equal to 1 plus 2v minus v squared divided by minus 1 plus v. You can write like v minus 1 if you want. You can write like v minus 1. So dv terms I'm taking, v and dv terms I'm making separate. Now what I'm doing is like I'm taking variable separable method. I'm doing now from here onwards, I'm writing variable separable method. I'm doing this problem like variable separable. So what is the variable separable method? V and dv terms one side. So v terms I'm taking this side. V minus 1 divided by 1 plus 2v minus v square dv is equal to dx 1 over x. So v terms and dv terms came one side. I separated variables v and x. So once if I variables are separated, so differential term should be removed. So to in order to remove the differential term, so what I have to do, I have to operate with the integral operator, both sides. So every step you have to write actually when you are doing a problem in a particular examination, maybe at BTech level, you write whatever the theory I have covered. I am telling that you have to write, operate with integral operators. Then you do the next step. So for me, the space is very less actually, frankly, and I am taking digital slate to represent these things. So very difficult for me to take number of pages more and more and to write number of steps more and more. But you have to write like that in the examination so that the examiner will understand that you have knowledge. Otherwise, the examiner will think that you copied from someone in front of you, like. So that is very dangerous. So every step you write. So don't apply integrator here. You write one line. Operate with integration operator. Then you take integral operator both sides. Like that you do. And if you use any formula, suppose let us say if you are using some formula f dash x by f of x integration of f dash x by f of x is equal to log f of x. You write using the formula integration of f dash x by f of x dx is equal to log f of x. That you have to write every time. But I'm not writing every time because I told you space concern. So, okay. Now, this is the equation I got. So, now, what the thing is, so v and dv terms are separated and x and dx terms are separated. Now, right side, directly I can apply what is 1 by x dx is log x. Plus some constant you have to add. You can add. That is done, simple. But what about left hand side? Integration of v minus 1 divided by 1 plus 2v minus v squared. Frankly, there is no direct formula to solve this one. But it is looking like, bottom what is there in the denominator, that differentiation is there in the numerator. Whatever the term is there in the denominator, 1 plus 2v minus v square, if you differentiate it, that a differentiation term is there on the denominator, I feel. So let us check. In the rough, I'm going to check. So what is the term actually here? Integration of v minus 1 divided by 1 plus 2v minus v square. Is it right? V minus 1 by 1 plus 2v minus v square. Right. So that I want to solve dv. See, if you take f of x as f dash x by f of x formula, you know that actually integration of f dash x, it means differentiation of f of x. Bottom is f of x dx. We know that. What is the formula? Log f of x plus c. Now, if you think f of x is this one, 1 plus 2v minus v square, then what is f dash x? Differentiation of 1 is 0, differentiation of 2v is 2, differentiation of v square is minus 2v. It means 2 into 1 minus v. 2 into 1 minus v. But actually what is there? V minus 1 is there on the top and 2 also not there. So what I do is, I multiply with the minus 1, minus 2. Minus 2 into v minus 1. And I multiply with the minus 1 by 2 also. 2 cancelled, minus into minus cancelled. So same equation is there. I have not disturbed the equation. But why I am doing this? Because I want to use this formula. F of x by f dash x by f of x. That formula I want to use. So now minus 1 over 2 into integration of 2 into minus I am taking inside. It will become 1 minus v by 1 plus 2v minus v square. Now if you see, okay, 2 I multiplied, right? Okay, that's it. So minus 1 by 2 into. So now this is f dash x exactly. See, f dash x is 2 into 1 minus v. F of x is 1 plus 2v minus v square. Now what is the formula? Log f of x. Log 1 plus 2v minus v square. So this everything you have to do in the problem itself, not in the rough. Okay, I am doing in the rough because space concern. So you have to do everything in the direct problem itself, and you have to write this formula also in the, you can put in close the box and you can mention that I am using this formula, so that the examiner will understand it easily. Not understand, he definitely feels that okay, the lad is good and he is presenting very nicely. So that is a thought you have to create in examiner mind. So my final answer is like here, minus 1 by 2 into log 1 plus 2v minus v square. This is the thing. Okay, now I'm going to this page. Page 4. Okay, so v minus 1 over 1 plus 2v minus v square. This I have solved. Okay, After solving, what is the final answer I got? Minus 1 by 2 log 1 plus 2v minus v square. So this one minus log 1 plus 2v minus v square is equal to 2 log x plus 2c. So this, if you bring 2 log x, can be written as log x square, and I am taking this side, it will become minus log x square, minus log of something 1 plus 2v minus v square minus 2 log x, I can write like log x square is equal to 2c. So minus, I am taking right hand side. So what you will get, I am taking next page, log 1 plus 2v minus v square, right? Minus, I am taking that side. So log 1 plus 2v minus v square plus log a log x square, right? I think log x square is equal to 2c. Let me check. Log 1 plus 2v minus v square plus log x square. Okay, minus, I am taking that side. Plus log x square. Log a plus log b. I can write like log ab. Log 1 plus 2b minus v square into x square is equal to minus 2c. So log I am removing because e power minus 2c I can write. If you take base as e. Generally here one, frankly it is blundered, but as it is acceptable in engineering level, when you are using log, I'm writing here, when you are using log, actually base 10. When you are using natural logarithm ln, then it is called base e. But even though I am using log here, as per actually Gravel textbook, they are using log, but they are taking base as e here. So even so many teachers follow that the same thing. So I am writing that, but generally when it is log base 10, when it is using ln natural logarithm, that is called base e. Okay, that difference you should understand. So now x square into 1 plus 2v minus v square is equal to e to the power minus 2c. So x square. So now the question comes, the answer is almost done, but the answer is having terms or the variables called capital X and capital V, like V, not capital V or V. So why? Because we converted non-homogeneous equation into homogeneous equation. For that purpose, I converted my small x small y into capital X capital Y, and capital X capital Y into something like V terms came. Why? Because I put y is equal to Vx to make it to solve a homogeneous equation method. So finally I have to convert back. So what is the, how to convert? Firstly, V you have to convert. You know that y is equal to Vx. It means V is equal to capital Y by capital X. So capital X square into 1 plus 2 into V means capital Y by capital X minus V square means capital Y square divided by capital X square is equal to e to the power minus 2c. So capital X square plus 2 into capital X capital Y, I multiplied with x square minus y square is equal to e to the power minus 2c. Now one more thing is there. What is capital X and what is capital Y? Actually, to solve, to make it homogeneous, we have taken one equation. X is equal to capital X plus h. X is equal to capital X plus h. Small y is equal to capital Y plus k. So now that implies capital X is equal to small x minus h. H value is minus 1. So it will become plus 1. Capital Y is equal to small y minus k. K value we got 3. So you have to substitute that also here. Capital X square means x plus 1 whole square. 2 into capital X, x plus 1. Capital Y, y minus 3. Minus capital Y square, y minus 3 whole square is equal to e power minus 2c. You can write like c dash. It is also an arbitrary constant. Hope you can finally this you can solve. That is it is not a big thing. you write x square a plus b whole square formula, x square plus 2x plus 1 plus 2x plus 2, sorry, 2 into x plus 1 into y plus y minus 3. So you solve this one, and y minus 3 whole square a minus b whole square, expand it, and final equation you will get as a solution. Or you can stop it here also actually, but generally it is not correct to stop here. So please expand x plus 1 into y minus 3, you can multiply x into y minus 3 into x minus 5, something like that. So hope you can do that, but still why I solve it. Okay, I will do this one also. Let me cut this part. It is so now, so what I am writing is x square okay. Now x plus 1 whole square, it means x square plus 2x plus 2 plus 2 into xy minus 3x plus y minus 3 minus a minus b whole square, a square minus 2ab plus b square is equal to c dash. So x square terms, you take first x square, any x terms 2x, that's it. Here is minus 6x, 2 into minus 3x, minus 6x plus 2x minus 4x. Xy terms only 1, 2xy. Y terms plus 2y, here plus 6y plus 8y. Any y square terms? Yes, of course, minus y square. Any constant term? Here plus 2, here 2 into 3 minus 6, minus 6 plus 2 minus 4, minus 4 minus 9 minus 13 is equal to c dash. That's it. This is the final solution. See, I told you the final solution should contain the variables what they have given in the question called small x and small y. Till that point, you have to bring the solution. Otherwise, it is incomplete. This is called a complete solution for the non-homogeneous differential form. Now, once I will show you what we have done in page 1. In page 1, method 5, non-homogeneous form, we have taken dy over dx is equal to ax plus by plus c. Because of the c and c dash, the equation become non-homogeneous. So to remove that term, we have taken case 1 actually. Of course, case 1, case 2, there are the two cases. And in the case 1, I have to remove the c and c dash. So c and c dash to remove, I have taken x is equal to small capital X plus h, small y is equal to capital Y plus k. This procedure I have followed. And in the page 2, also same theory continued. In the page 2 also theory continued. So after substituting these two terms in the bracket, in the numerator and denominator part, I make it 0, so that I calculated h comma k values. Then my equation become homogeneous. If once my equation become homogeneous, I know how to solve. Even in the previous step we have done. So far till the page 2 we have covered theory. In the page 3 we have taken an example, and then we solved that equation. And even in the page 4 we got process of procedure. Still in page 5 it is continued. In the page 5 the complete solution we got. So this is what actually, this is rough. Okay, you no need to consider this part. This is what we call page. Is it page 4? Page 4. This is called page 5. Okay, this is page 5. Now in the rough page we have taken rough page to support our procedure in the problem. In that two things we have taken this formula integration of f dash x by f of x, how it become log f of x, because that term came in our problem. So I have taken this one and how to do this thing. And this also, if 2, 3 variables are there in linear equations, how to solve by using calculator. You can do that by using calculator. Please try, don't waste time. And if it is a quadratic equation or cubic equation, also can be solved by using calculator. Here you will get 2 roots, here you will get 3 roots. If it is a second order equation, you will get 2 roots. If it is a third degree equation, you will get a 3 roots. If it is cubic equation, if it is a 4 roots, 5 fifth power, you will get a 5 roots, like that. But here remember, it is only one variable called x, but here variables will be varied. It means it may be 2 variables, it may be 3 variables, it may be 4 variables, like in the linear equations. So that's it. So next in the next session we will see non-homogeneous equation of this form in the page 1 that I have mentioned, called if a by a dash is equal to b by b dash, how to solve. That is as we think, like it is a method 6 it will be. So that we will see in the next session. Thank you all for watching this video.